Hello there, ladies and gentlemen. Welcome back. Today we'll be looking at the properties of functions. We'll be looking at the average rate of change, using the graph to determine if a function is increasing, decreasing, or staying constant, using the graph for even versus odd functions, and finally using the equations to see even versus odd functions. Let's get started. Alright, this is the formal definition for average rate of change. It says that if c is the domain of the function y equals fx, the average rate of change is defined as delta y over delta x, which should look familiar, equals to f of x minus fc over x minus c, where x does not equal c. Looks kind of weird though. Let's take a closer look. Alright, the average rate of change in a straight line you've done before. That's actually just a slope. So you don't have to say the average rate of change, you just say the rate of change, because it's the same throughout. But here, what about something like this? Here we're given some function. We're saying that y is equal to f of x, and we want to know if we chose two spots, let's say here and here. If we want to know how much it changed between that and that, well, what we would create is a line between them, something like this. And you would say that this is a secant line because it touches the function in two places. So we created a secant line, and let's say that this point, we called it, we'll say this is x. That means that the y, instead of just calling it y, it would be f of x. And here we're going to say that this point is c, therefore the y should be f of c. If you look back at your average rate of change formula, delta y over delta x, you know that just like before, like for your slope, you're just subtracting the y's over subtraction of the x's. So that's why you get f of x minus fc over x minus c. So it's actually not as complicated as it looks, because you've done it before. Let's go ahead and try one out. Alright, we're going to start off with a linear function, and they're asking us to find the average rate of change from 1 to 2. What's happening in this function from 1 to 2? How much is changing by? So I'm going to go ahead and I'm going to use this one as my x and this one as my c. Now notice that I have to find out f of x, so that means that I have to find out how much f of 2 is. Well, that's 5 times 2, which is 10. I also have to find out how much f of 1 is. That's 5 times 1, which is just 5. Now I have all the information I need. I know how much f of x is. That was my 2, so that's 10 minus f of c, that was this one, 5, over, now my x's, 2 minus 1, 5 over 1, and there you go. My average rate of change here is just 5. Please notice that if you had chosen this as your x and this one as your c, you would still get the same answer. You're going to get 5 minus 10 over 1 minus 2, which is negative 5 over negative 1, so it's still just 5. Let's try some more out. Alright, same as before. Here I'm still wanting to find out the average rate of change from 1 to 2 in this function though. So I first need to find out how much my f of x is. What is the value when I input this here? So f of 2 is 2 squared minus 2 times 2. That's 4 minus 4, so 0. F of 1 is 1 squared minus 2 times 1. 1 squared is just 1, minus 2, so it's negative 1. So here, I'm going to substitute it in, and I get negative 1, so this was my x. So 0 minus negative 1 over 2 minus 1 is equal to, remember this is a plus now, so it's 1 over 1. my average rate of change here is just 1. Alright, last one for me. Let's go ahead and do this one. F of 2. Substitute that 2 in here, plus 1, that's 2/3. F of 1 is 2 over 1 plus 1, that's 1 over 2. Okay, so even if you have fractions, don't worry about it. So here I get 2/3 minus 1 over 2 over, sorry, this should be an equal there, over 2 minus 1. Alright, don't forget you need to have the same denominators, multiplied by 2 and here multiplied by 3. I get 4 over 6 minus 3 over 6. Okay, over 1. So since over 1 is going to stay the same, I don't really need it. And here my final answer is 1 over 6. And there you go. This is my average rate of change for this function. Alright, you have 3 problems on the board. Go ahead and find the average rate of change from 1 to 2. Pause the video and I'll show you the answers in 3, 2, 1. Here are the answers. I hope you got them right. Alright, if they give you a graph and they're asking you, hey, where does it increase, decrease, or stay constant, then all you really have to do is look at your graph. Now what they want to know is from what x to what x does it increase, decrease, or stay constant. So, for example, going from left to right, if I were to use my pencil to make this graph, to follow this graph, from -4 to -3, my pencil is going up, so it's increasing. What's actually happening is that, let's say this is f of x1 and this is f of x2. You're saying that since it's increasing, this one has to be less than the other one, okay, because each subsequent one's getting bigger and bigger. So all the points here in between are getting bigger and bigger each time. So you would say from -4 all the way to -3, my graph is increasing. And then notice what happens here. Now here, let's say this is f of x3. Notice that it's decreasing. That means that my f of x2 is greater than all my numbers because it's getting smaller and smaller each time. And as a matter of fact, if I keep following, I notice that it's still going down until I get here, okay, where my x is 0. So I'm going to say from -3 all the way until my x is 0, my graph is decreasing. Notice that it increases again from 0 all the way to 3, increases again, and then it stays constant because let's say this is f of x4, f of x5, and f of x6. Notice that these, okay, and everything in between is the same. So that means that everything there is constant, the same. So we say from 3 all the way to 6, it is constant. And there you go. Alright, if they give you graphs and they ask you, hey, which one is even or odd, this is what they're actually asking you. If a graph is even, that means that it's symmetric about the y-axis. And you've done those things before. If a graph is odd, it's symmetric about the origin. And there's neither. So this time you only have even, symmetric about the y, odd, symmetric about the origin, or neither. Right? Using algebra though, if you want to test if a function is even, what you need to do is replace that x with a negative x, and if you get the original equation back, then your function is even. That means symmetric about the y-axis. To test if it's odd, notice that once again you'll be putting in a negative x, But what you want is not the original. What you want is the negative of the original. Okay, if you get that back, then it is odd and it is symmetric about the origin. Let's go ahead and test this one out. Here I'll be putting in f of negative x equal to negative x squared minus 5. But I know that whether something is positive or negative in here, if it's squared, it's going to be positive no matter what. So this is actually just x squared minus 5. And notice that I get the original back, and therefore I know that this function is even. Let's try another one. Alright, here I'm given h of x is equal to x cubed minus 1. So I'll be putting in h of negative x. So negative x cubed minus 1. Now here, if something is negative, it's going to stay negative. Why? Because you have negative times a negative, positive. A positive times a negative, it's going to be negative no matter what. So here you actually get negative x cubed minus 1. Notice that this is neither the original or the complete opposite of f of x, because the complete opposite of this one will look like this. Negative x to the third plus 1. Alright, here look at what we're given. We're given g of x is equal to 5x cubed minus x. We'll be finding out g of negative x. So 5 negative x to the third minus negative x. Here, once again, it's to the third power, so no matter what, this is going to be negative. So since it has a coefficient, I'm going to put that in front. So negative 5x to the third minus negative, so that means plus x. Now here, notice that each term has now switched signs from the original. To look at it better, if I factored out a negative 1, this is what you get. Negative 5x to the third minus x. Notice that now you have what you're looking for. If you're looking for odd, you have negative and here you have negative and you have f of x. This is f of x. 5x cubed minus x minus x. So this one we say is odd. G of x is odd. Now it's your turn. Alright, you have 3 questions up on the board. Go ahead and pause the video. Tell me if these are even or odd. I'll show you the answers in 3, 2, 1. Here are your answers. I hope you got them right. Looks like that's it for today. Until next time.